Hello, welcome everybody to today's webinar concerning K2 Base. I hope that you can all hear me. I hope you're in a good mood and ready to go. So what I plan to do is just make a short calculation with K2 Base, show you some tricks, and then show you the most important things, features, and then afterwards we can have a little chat, or yeah, you can ask questions always via chat, and my colleagues who support me will answer your questions via chat. And you can also use the hand sign, and then maybe in the end we can have some questions via audio. So let's start now. So here you see the start page of K2 Base, different icons which should be obvious, which you already know from other Windows applications or something. Yeah, open a new project or create a new project, open a existing project, load data from your app, or using the help functions with FAQ. You also find these icons up here, and in addition, the icon for saving a project and for downloading a project on your computer. The difference here is saving a project means you save it within your account. I am now logged in as webinar moderator, so you can only use this function once you've registered and logged in. Here you can choose language and yeah, the system, metric or imperial. Yeah, coming back to save the project on your account, or here save the project on your computer. On the other hand, if you want to open a project, you can then open a project from your account. These are projects which are saved in my account, or I can open a project from my computer, and afterwards here a browsing window will be opened as you know it from Windows or whatever system you use. Okay, I won't do that now because I've already started with this project. Here we navigate via this these icons here, or these words, starting with the address. So now I've already typed in an address here, including the street and number. I can, yeah, this would be one option, or the other option would be, you see now this is our address. The other option would be that we move to the place we want. We can zoom in a little bit. Okay, now something happened. I don't understand it at the moment, but it's not so important. The other option would be just double clicking, and once I double click on my address, yeah, you see that here the address has changed up there. Of course, you can also fill in this stuff and then move on to roof. In this case, we want to create a new roof by using the plus icon. We have a flat roof, which is rectangular and has a membrane or substrate or gravel. This is what we choose later on. So yeah, for creating another roof, you just use the other icons here and the other surfaces. So now I click on add, and question which comes a lot is why can I not create a roof? Well, this is in most cases because people keep the mouse button pressed. This is not good. You must release the mouse button after clicking once and then move it. We create the first edge of our roof, then we click, and then we move the mouse button again. And it doesn't have to be perfect in size, because later on I can adjust with the mouse. First, I give all the needed information, which is marked red here. The building height, let's say it's 10 meters. Roof pitch is maybe 2 degrees. My parapet wall is, let's say, 20 centimeters. And the friction coefficient I have measured before with our friction coefficient determination tool, and I measured 0.95 in this case, because I have a roof with substrate and green. Another option to alter the size of the roof, besides using the mouse, is going to the 2D view up here. But before we do that, we want to change into the expert mode, because now we have the easy mode for making a quick calculation before, and you see we don't have so many possibilities to choose some options here. So let's go to the expert mode. Now the expert mode is on, and yeah, in this case doesn't make a big difference. We only see that we have a roof type here, flat roof. So, but I recommend to use the expert mode if you have measured all the values of the roof, if you know something about your roof. So what we forgot is to choose the roof material. In this case, I said it's a green roof with substrate. And now, as I said, let's switch to 2D view, because only in 2D view we have the possibility to alter the size of the roof by typing in a value here. Let's say we have measured 16.5 in advance, and now I can say that the alternation has to take place on the right side, on the left side, or on both sides equally. Please also check the other symbols here, which might be really useful. But now first, let's go back to the map view, because we have some obstacles here. So we go to the obstacles area and have now the possibility to draw polygon obstacles or rectangular or just a line. So let's make a rectangular obstacle first. Tiny little obstacle. As you can see, the first line is always parallel to the roof, and it jumps rectangularly. And when I don't want to have that, when I really want to have a diagonal or not a parallel line obstacle, then I push the shift button on my keyboard. Once I release the shift button and I move the mouse again, it jumps back to a parallel position. So let's also here make a obstacle like this. And I also can alter the size of the obstacle afterwards. I can give my obstacle a height and an additional distance Let's do that too, 20 centimeters. And I can also show the shading. Yeah, let's make it a little higher so that we can see the shading better, just for demonstration purposes. Now we can see the shading on the 21st of December. Let's go to the 2D view to have a better look. Now you see the shading, you see the measurements of the obstacle, which you can also alter by typing in another value here. And also consider this icon up here, because there you can switch from seeing the measurements of the obstacles to seeing the measurements or the distances from the obstacles to the roof edge. I can of course also alter these values by typing in something else. So let's go back to the map view. We have another little obstacle here. Let's make this polygon like this. Now, nice little obstacle. Of course, I can also give it a height and minimum edge distance, which I don't do in this case. So let's proceed to design, and always think about saving the project from time to time. Project saved. Oh, I clicked twice. Doesn't matter. So let's go to this area first and choose a module. Here you have the possibility to choose between different module manufacturer. I already decided to take a Axitec module here, and of course we can also choose the different modules, and we can use the search function. Of course, I could, for example, say that I want to use a 330 watt module, and then only 330 watt modules are shown here. Let's take this one, and now I have my measurements and my output power, and I could go to user defined if my module would not be here, and then just typing in all the values afterwards. So let's go to module arrays, draw a new module field, and let's do now for the beginning DDOM V system. We put it on the complete roof. DDOM V is always elevated and landscape. I cannot click on the other fields here. So when I go to add now, then my whole roof is full of modules, but in the areas of the obstacles, of course, automatically there are no modules. We see that we have 64 modules here, and the output power is 21 kilowatt peak. Let's go to the 2D view now. Well, let's optimize that one a little bit, because I would like to have some more modules. You see, I have a little more space here. Let's see if we can do that. So now I cannot move the module field. I can only move the whole roof. So let's go to the edit function here. This little pen means that I now can modify my module field, which I will do. I take it here using the mouse, make it a little smaller. Let's make it even smaller by altering another value here. Let's make it only 2 modules, which means 2 double modules. 1, 2, 3, 4 modules in all. So the alternation has to take place on the right side, so all the modules will disappear here and only these one will stay. Now I draw another module field. Now I use this icon module field because I don't want to have a complete roof cover again. And we make some modules here. We can now use this button for minimizing the unnecessary space around the modules. Put this one maybe a little further here. Make another module field, which we can put here. So now it's in the shadow. So maybe I don't want this one. I can use the rubber function. Just delete the module by clicking and make another module field. So let's use the rubber again because I want to show you some special rubber functions. I already showed you that we can just click and then the module will be deleted. If I click again, then the module will be there again. If I want to delete a whole row, I use the control button on the keyboard, keep it pressed and then click the mouse. If I want to delete a whole column, I use the shift button, keep it pressed too, and then click. And if I click again, all the modules are there again. If I want to delete a whole area, I also use the control button, keep it pressed, keep the mouse button pressed while I move the mouse, and then release the mouse button and then release the control button. So that's mainly it. I wanted to show you, that's, as you can see now, I cannot save or I cannot move on to the loads calculation. So I first have to finish the deleting mode. And after having done so, I can save my project again. Which is done now. So you see we have 4 module fields here. Coming back to this function, editing a module field after having made a whole covering of the roof with a one large module field. This gives you more flexibility. In this case, you see it might be that because of the obstacles, you get some modules less because all the modules are in the same pattern, and to get out of this pattern, it can make sense to make several module fields instead of one large roof covering. So as you can see here, I'm quite flexible. I can move this. Now it's activated. You can see that on the little dots. I can move this a little further here, a little further there. It's no problem. Yeah, having one large roof covering, this would not be possible. So, but anyway, let's for now let's for now delete all the module fields, yeah, because I want to show you another function. So now all the module fields are gone. We make a new module field with a SDOM V in this case, and let's put it on the complete roof. Now, looks a little different already. Next thing I want to show you is the thermal gaps. In this case, we see that we have a thermal gap every 10 modules and every 9 modules in the other direction. So the maximum module block size is 10 times 9 modules. And if we click on this button, we see there is no thermal gap in this direction because we have only 8. So if the roof was bigger, there would be one thermal gap after 10 modules. We finish that, go to this view. We also don't have a thermal gap in this direction, but we can create one. For example, here, I just click on this red line and it becomes yellow, and then I click the checkbox, existing thermal gap, yes. Now we have a thermal gap here. I end that mode, and then we see the modules are divided here. Of course, it's also possible in this direction. So let's put a thermal gap here. Of course, I could also just type another value here. Let's say make a thermal gap after every 3 modules. Now you see we have 1, 2, 3, 1, 2, 3, 1, 2. Counts always from the downside. Same in this direction. 3. 1, 2, 3, 1, 2, 3, 1, 2. Yeah, it's just for demonstrating, just for showing you how these functions work. So let's go to loads. In this case, we are in Germany. So we told the tool already that we have this zip code here. So, and on this zip code, the tool knows that we have wind load of 0.45 kilonewton per square meter and snow load of 1.26 kilonewton per square meter. If your project is not in a country with a national attachment, yeah, some countries don't have this automatic calculation, then you would have to type in the values here by your own. Or let's say, let's make it 0. Let's make it 0 here too. This would be the situation. You always have to type in a value for the wind. Yeah, in this case, in Germany, I also have to type in a value for the snow, but of course in other countries, this is not mandatory like here. So, but I also can go back to input type postcode, or just click on this button here would also work. And the values would be there again. So let's go on, change to results. Now we have our ballast plan here. I can zoom in a little bit. Now you see here the ballast values. You have to put these ballast, these values on on the specific point. The ballast is calculated on base of the wind speed, the friction coefficient, but also on the module field size. So if we go back to design now, keep in mind that we have, for example, here 14, 19, 38. So we go back to design, delete these. Oh no, let's go to the 2D view first. Remember that we have a thermal gap after every third module. Now I can check what the maximum value is. So I type in 20, and when I confirm that by using the tabulator key, it jumps back to 10, because we remember that 10 was the maximum module block size which is allowed. I do the same thing here. I type in a very high number, which is not possible, and by confirming it jumps back to the maximum allowed number. So let's go back to results. It's calculated again, and you see the ballast values are much smaller now because we have larger module fields, and the larger one connected. Now all the modules are connected. We have no thermal cut anywhere. And that means the system itself is much more stable in this case. So let's have a look to the ballast options. Usually you can put the ballast on the rail itself. About 20 kilogram is possible. You can also lower or higher these values if you know already which stones you will use, and if you have experience with the system, you can say, I want to use the extra items for ballast station speed porters, or you can say, I don't want to use porters, for example. In this case, none of it will be necessary because we have so low ballast values. It will be enough to use the rail in all the cases, probably. Here you can choose other extra items like lightning protection, equalization items, or cable management. You can also switch in another view. Now you see 4 kilograms, 7.5 kilograms. You can also show the ballast in stones, number of stones. So if you say that your stone has, let's say, 4 kilograms, then you see that you need 1 stone, 2 stone, 1 stone, 6 stones here, for example. Yeah, these two options you have. You go to load on modules. You can check by clicking on a module what the loads on your modules are. If the module is fine with that, please check that on the data sheet or the assembly instruction of your module manufacturer. If we go to this area, we can see that everything is in order. We can see the pressure and the suction on the system too, and you see the values are quite low. So we have the system is verified in this case. So finally, let's go to summary. Now you see yeah, the summary. Roof 1 with S-dome, 45 modules. You have a bill of materials here, which you can even edit. You can say, okay, I need maybe some speed porters in extra. I don't want to use 10, but I want to use 20. And you can even add some other items here. This is not possible because we have this item already in the list. But yeah, theoretically, you could add other items here. So let's confirm this. Now you see which you have changed, which item or which quantity you have changed here. So let's save the project. Finally, let's download the project on our computer. Now it's in the downloads of your browser, and you could take it, attach it to an email, and send it to your colleague who will work on with this project. And one important thing, of course, is the generation of your static report. Let's, in this case, not save it, but open it only. So now we see here let's make it a little smaller. All my project data, the modules, the loads, then a pre-assembly plan for your rails, then the view of the whole roof, then a detailed view of the rails, the ballast plan, and now the results concerning loads and the analysis of the under construction itself. Different calculations, and here the confirmation that your system has been verified. And in the end, you have the bill of materials. So I will just have a little look. If we have any questions. One second, please. So yeah, there is one question about what the thermal gaps are for. Let's go back to this point. Yeah, imagine you have a larger roof. Yeah, so in this case, I can show you how to add another roof. So let's go back to the roof area. We have now roof 1. Let's say the owner of the house wants to have another project, and he wants to build a new house just right here. So what to do if we don't have the building on our satellite picture yet? We just go to add a new roof. Let's make a gable roof in this case. Let's make it rectangular, and let's put tiles on that roof. So we go to add, and now I just draw my new building, which does not exist already, just on the field. I can put it everywhere. So let's give it a building height to roof pitch, or let's say 30 degrees, and rafter spacing. So now we see that this is the ridge and this is the eaves. We can see that because of this little arrow. When you made a mistake here, it's no problem. You can adjust it by using one of these two buttons. Now you see the eaves would be here and the ridge would be here. So let's go back by using the plus button in the first position. Let's go back to design. Don't forget to choose a new module or the module once again for your second roof, because now you see this is the module we used on the first roof. We want to use this module again because this is now another module. So now we have the right module. We go to module arrays, plus, yeah, let's choose single rail system, complete roof, parallel to the roof, and let's make it portrait in this case. So now we can already see little gaps here. Let's go to the 2D view again. So here you see we have a thermal gap now. And we see that the thermal gap is after 18 modules. Yeah, 18, 18, and some less. So now, why is that? We need a thermal gap because the rails are made of aluminium, and imagine you would have a continuous rail over the whole roof. This rail would be 48 meters long, and the expansion, because of warmer days and colder nights, for example, would be immense. So this would have a bad effect on the roof hooks and on the roof itself. So this is why it's necessary to have a thermal gap after some meters, yeah, and this is different from system to system because each system has its own specifics, specific characteristics. So for example, for a speed rail system on a trapezoidal roof, 8.6 meter is the maximum rail length. And you can see for a single rail system on a tile roof, 18 meters and something, 1830, I think, is the maximum rail length. So 18 modules. If I say no, I want thermal gap after 19 modules, it's not possible, it jumps back to 18 by itself. So let's have a short look. If I can find some other questions to answer. So we have another question that somebody had a error message about the rail length. I suppose that what is meant here is not the rail length itself, but maybe the length of the cantilever. So let's go to the results page to have a brief look on that. Let's zoom in a little bit, and now you can already see messages. One or more components are overloaded. So let's see which these components are. And yeah, as I expected, it's the cantilever. Cantilever length too long. So we can see that it's at the eaves, so it must be down here. Let's have a look at the cantilevers. We don't have a cantilever here. We don't have a cantilever here, but we have a cantilever here because the rail goes further than the last fastener. So let's click on this rail, then it gets red, and then we have more information on this side. As I said, on the right side, no relevant cantilever. On the left side, maximum length of the cantilever is 461 millimeters, but it's too long. This is a good situation, good that this happened, because now I can prove what I said before. Let's have a look on this icon here. By using this icon, you can show or hide several several information, for example, the roof zones and the roof structure. Let's have a look on these two facts. The roof zones. Let's hide the rails in the meantime. And the fasteners too. Now we can see we have a yellow color here, gray color in the middle, red color here. So let's show the rails again. And let's show the fasteners again. As I said, we have a problem in the eaves. So let's click on this rail. Oh, we have also a cantilever problem here, for example, although this is not the eaves. Yeah, but the problem is, as you can see here, there is one fastener on this rafter, but there is no fastener where you can put the rail again after it is fixed on this rafter. So we have to solve that problem, and we have to go back to design for solving the problem. Let's go to the 2D view. Also in the 2D view, we can show the roof construction, that we can see the rafters. We can hide the modules for a little time, then we can see the rafters better. No rafters, rafters. No modules, modules. Solving the problem after having made a roof cover, a complete roof covering, is very, very hard. Or no, it's not hard, but the best option to do that is just editing this complete roof covering. No, this should not happen actually. We have a thermal gap here, which should not be there. We delete it. It's always nice when things like this happen in a webinar. It won't disappear again. Don't ask me why. I hope my colleague watches, who's responsible for that. So yeah, sometimes things like that can be solved quickly. So yeah, let's go back to our problem. We have a cantilever problem here and we have a cantilever problem here. So we must now edit the module field size. So let's make the module just smaller. Let's make the module field just this size. So let's go to results again. Now we see that the module field starts on the rafter, and here the next fastener goes to the next purlin. Let's go back to design. Let's use this button and minimize the size of the module field so that we have no extra space around it. Let's put it a little in a better position, just right between the rafters. Now what we can do now is we make a new module field, just a module field, not a complete roof covering. And then we place this new module field just onto the rafter so that we cannot have a cantilever problem in this area. We make it 18 modules wide, and we want to take the 8 modules more in this direction, like this. And then we make it like this. Make it to the ridge. So now if we go to results again, we see no message anymore. Verification, everything is in order. No cantilever problem. Of course not, because we have a fastener here, a roof hook, no cantilever. We have a fastener here in the end too, and the same thing here. There is a fastener, and now this rail can go to the next fastener. That means when I make the next module field, I remember that the rail was going until this rafter here. So when I make another module field now, I have to start it somewhere here, let's say. There's no need to make the module field complete in the first place. Just make it like this. Yeah. Make it a little larger. So let's go back to results. You see, everything is in order, so I can realize my project. So there you see that it makes sense to make module fields instead of a whole roof covering, or if you have a cantilever problem after having used the whole roof covering, then editing that and divide it into several module fields. And think about, let's zoom in a little here. You must not make the module field. Nah. We remember that the rail for these modules were going until here. So we need that rafter for this module field. We cannot use this rafter also for this module field. So once we do that, if we move that like this, Let's have a look what happens. Let's go to results. Still everything in order, so we were lucky. Yeah, because the modules did not move too far in this direction, and the cantilever here is not too long. We see the cantilever maximum length is 471 and the actual length is 371. So we have some more questions. Let's go back to the other roof, the flat roof. Yeah, that was roof 1. By the way, we can also give the roofs another name. Like, for example, yeah, we could call it flat roof, or we could also call it no, that was room. Living building. Oh, is it a living building? Does the building live? No. Let's go to design. So the question was, how can I alter the orientation of the modules? So of course everybody would want to have these modules oriented towards south, but other buildings would maybe have another direction. So it would make sense to alter the direction of the modules. For that, you just press this little icon with the M, which stands for manually. So we can manually alter the orientation. So we now choose our personal north. So we click on this roof edge, and then the green line goes to the east side, and my modules are now orientated into this direction. Yeah, so we have a good output in the evening when the sun comes from the west. This was one question. Yeah, by the way, we would also have the possibility to adjust this a little bit by maximum 15 degrees by using the plus and minus keys here. Let's go in the other direction, or but just by typing in a value here. Maximum value is, as I said, 15. So let's type in 20, and it jumps back to 15. Now you see that the modules are not parallel to the roof edges anymore. We could also make a minus in front of the 15, confirm it with enter or tabulator, and it goes in the other direction again. Yeah, here we have an interesting thing. We have this module which stands alone. It has no connection to any other module. So why is that? So we would have to delete this module in that case. Just make it away. Everything is in order. The module does not exist anymore, and we could go to results now. So Another question would be what to do with a polygon roof. So polygon roof, for example, yeah, here we have a highly polygonous roof. Oh, I really don't want to use that as a sample, but this one would be nice. Let's choose this one. It's a little easier even. So let's add a new roof, this time a flat roof with a polygon shape. So we choose the first roof edge like this. Oh, this has some tiny little edges too. I will ignore the first one. So you can see it always is in a 45-degree angle or in a 90-degree angle, nothing in between. And in the end, I push the control button to have a rectangular shape in the end too, and I finalize by double clicking. And then already I have my polygon roof. And the rest would be similar to a rectangular roof. Not a big difference. So yeah, let's delete this roof again, because there is one thing I still want to show you. In the end, I forgot that before. I showed you the static report, but what I did not show you is two other important things. Yeah, well, three things. You can now show the bill of material for the whole project, roof 1 and roof 2, or just for one roof or the other roof. Yeah. And the second thing I want to show you in the end is downloading the bill of material as an Excel file by using this button, and switching to inverter design from Fronius, SMA, or SolarEdge by using this button here, and then continue making your inverter planning. So yeah, I would say, let's go back. Yeah, thank you very much for taking part in the webinar today. I hope you enjoyed. I hope I could show you some useful stuff. If you have further questions, don't hesitate to contact us via email or via phone call. Just call us. We are always there to help you. So thank you again for watching, and now I say goodbye, but as I said, we are still there for some seconds. Bye guys, have fun using K2 base.